Before we start implementing any complex types, I'd like to get a utility type out of the way. And to motivate that, I want to go through a thought experiment. Let's imagine we have a data structure of a shape, which is a map of some sort that has a set and a get function. And the get function returns an object of the generic value. And the question I want to ask is, what do we do if the key does not exist? What do we return then? Do we return null? Do we return undefined, or do we want to throw an error? Well, we don't really want to throw an error. That'd be kind of annoying, especially since there's also no way of enforcing it. And just imagine writing the try catch every time you want to use the map. That'd be just obnoxious. So what about a null or an undefined? So we could write something like this map here, and the function could, instead of returning just v, it could return v or undefined. And when we use it, we can just call the get function and then check if the value is undefined. What if our v contains undefined, if that's a possible value? What does it mean when we get undefined? Is the key missing, or is the value just undefined? That can be a very big difference. And this motivates the maybe type. That is a type that is either some value or no value. And if the map instead returns with some type, then we can check was the value actually present or not, independent of what the actual generic type is. Let's just start with a basic framework. We know we are going to have some interface. I'm going to make some interfaces. So we know we have some interface called maybe. We don't know if it has yet any properties yet. So let's make my ESLint just shut up. We know we have some type sum. We also know they have some generic argument. And we have a type called none. They also extend the maybe type. That takes care of our base framework, and we can concern ourselves now with what feature should this maybe actually have. Well, first of all, we want some ability to get this sum out of there, because it's nice that we get a sum out, but how do we get to the value? So let's extend this with a value. Let's call it sum. And none, what should that do? It should actually never have a value, but it makes no sense for none to have a value. So we can now also write some utility functions, because we now also need to know, is something actually sum or not? And with that, I'll introduce the type guard. Let me just write one out first. So what is a type guard? Type guard is a function that returns a Boolean value. And if the Boolean value is true, then we know that the argument maybe here is going to be of type sum_t. So this is a method of telling if the option or maybe that we got back isn't actually the sum type or not. We'll look at a use case of this in a second. I'll just add the one for none as well. And we can just call the is sum type guard and just negate it. So how is this useful? Let's say we have a value, we don't know what it is, which is of just a maybe here of, let's say, a string. And we can assign the just value some value. And at this point, we have technically a sum here, but since a sum extends a maybe, this is fine as well. If we want to know now if this is a sum, because if we tried to access the just in value, this wouldn't work. So const extracted. This will be an error. It tells us property just does not exist on type maybe. It doesn't really work okay, there we can read the error. Does not exist on type maybe string, which is correct. What we can do instead now is ask the question first, is sum value? And if we try to access them here now, we can see this works now. And if we ask if it's a none, we also get the error that just does not exist type of none. If we now go back to our example with the map, if we just return here a maybe, now we could ask afterwards if it's sum, then do x. If it's none, then do the other thing. That is pretty much it as far as sum and as none is concerned, but it would be nice to have some utility functions. The first function would be the just constructor types, factory types. And this will return a sum of t, and we can just return the just t. Yeah, just. So we can do the same thing for the none. I'll stop the bracketing here. We can just return the empty object because this none doesn't have anything. Let's also export all of these things, because that would be very useful to actually have. We don't need to export none and sum. We only need to export the maybe. And let's think about some more utilities. Those come from the functional programming world. They're very useful. Quite often, we don't want to ask if it's sum, if it's not none. We just want to transform the value a few times, regardless what it is, and then just hand it off to some other function that can deal with it. And such a function is usually called map. So let's add this here. Map is just a function that takes a value of t and returns a value of r. Let's rename our generic parameters a bit. This is the actual value, and this is the new just. Let's also call this just. And also this just. Just give me a second. Now, we also already see one of the advantages of TypeScript. It immediately tells us that we extended our type and we have an issue here. We cannot forget fixing our types here. It's just telling us that map is missing. That is correct, map is missing. And this is not how map should look like. It should accept a function that does this, and it returns a new maybe of type new just. It of course needs to accept a mapping function. We can't know how to map at this point here. So we get the mapping function, and what we can do is just the sum of the mapping function of the original just value. That's all we need to do. And for the none, we can return the function that returns just the none again. There is no need to do anything here, because a value that is missing can't be transformed. It just transforms to the container of the new just here with still no value in it. Let me just bracket this slightly differently so that I just like it this way. You don't have to do that. We can do furthermore one thing. That is, if we already know we are a sum, then we can also return a new sum. And we can look at this in a second. And in the case of the none, we also know we are going to return a none of this. We can actually even simplify it like so. Not with the linting rules I have. This doesn't matter. We know we are going to return a none. So what does this mean? If we actually have a value here that is a sum, and we call map on this, and we want to transform the x, let's say we square the value. Then we can access the just here without an error. Because TypeScript already knows we are a sum, and a map over a sum yields another sum, not a maybe. On the other hand, if this was... just a second. If we make this a maybe of number, then TypeScript will tells us it doesn't know it's a sum anymore. So it'll give us the error. And there is one more piece of functionality I want to add, and that is a pattern match. This is again from the functional world, but it is incredibly useful. Let me just type it out again. So we are going to accept two functions. One function is going to be called onSum, and it will be called when we are a sum, and a onNone, which will be called when we are a none. And it will return one or the other. Since in the sum we don't know which case we are, we'll return the union of both types here. We can do the same trick we did down here and overload and move this to the actual maybe, and overload this. Since we know we are in the sum type here, we can just return the value, the same type this function would return. And in the case of the none, we already know we're going to be only calling the none, not the sum function. Again, TypeScript will tell us nicely that we need to do something, so we can implement our match here. It'll take two parameters, onSum and onNone. And we can just call onSum on just again. We can do Down here, the same thing. I'm using underscores to symbolize that we're not using this value. Let's suppress this, because this is intentional in this case. And we've got this set up. Now, what is the use of this? Well, if we want to, for example, say, we don't want to type out the if-else, we just want to have handlers for how to deal with it. So we could accept it from the outside of a function. So we could do some value, which is a sum, for example. And then we can just do x.match, and we can provide this to functions. For example, this would discard the just value. We could accept the just value here as well and just, for example, add them together. Now, TypeScript will know that y is of type string at this point. This is the type hint. And it knows it because we are in a sum. If we turn this into a maybe, it will not know that anymore. It will tell us that we are either a string or a boolean, because the none is returning a boolean. And if we turn this into a none, then it will tell us that we are a boolean. And this is a very type-safe way of actually accessing our values in here. And we could here then do something. For example, we fetched a user and we want to update that user's email. So in this case, we could do then update email just with new email. And on the negative case, we could do something like response user not found. User not found. Respond. Let's call it that. So if we imagine this would be on our map, this would look like map.get user ID .match, and then the two functions. We could then also accept these two functions as arguments to the function trying to do this. And this would be a very generic piece of code that could do everything we wanted to without us having to write custom codes, without us ever having to actually use the is-sum, is-none here manually. We can just get to the values through this match. One maybe interesting thing to look at would be the tests. I have written them in advance. And to just look at how would we actually test something like this. So in this case, we're just testing if is-sum, this is-sum function is true if we feed in a sum. The same thing for is-none if it's false if it's a sum. These are the two equivalent cases. Then here we check whether the item we put in is actually the item we get out with just a few different objects. We are testing the mapping function here, so we put in some value, we map it, we fetch it out, and then we check if it's the actual value we computed here. Same thing for the none. We expect is none to be true if we call none.map. And then here we have our pattern matching test, that if we are a sum and we match the positive one, then we expect this function to have been executed and it to be the value of this function, and the same thing on the none. What's more interesting is, how do we actually test our types? Like, how are we confident that our types are anywhere close to correct? And this is one way of doing this. We can just access them. These are constants. They're not being exported and they're in the test file, so they're also not being built in the final product. And TypeScript will just try to compile this. And if the compiler doesn't fail, then we know that our tests are correct. Might seem a bit janky. And it doesn't work in all cases, but in this case it will work. So we can from sum access just. So if our sum type wouldn't have this just, let's just remove it from the sum type. Then we'll see TypeScript will actually throw an error here and not compile anymore. Or at least our tests will not compile anymore. Here, the same case for the inverse. We expect none to not have just. And there's this annotation here that tells TypeScript that the next line will cause an error. And if it doesn't cause an error, then it is an error. So let's add to the none type, the just value. Like so. And we'll see it immediately throws the error that the expected error wasn't used. That's one way we can verify whether properties exist or do not exist in our types. Here we match the, here we make sure the sum actually collapses to just the number value, not the union, because the on none is the string. We're testing here if the none collapses to only the false case. We are then testing whether the on the maybe we are defaulting to the union because we don't know which one we are. And then we're testing that whether we did not collapse. Like if we are on the maybe, we do not want to be just number. It needs to be number or string, and this should be definitely a string. And with that, we have tested all these functions here just through the compiler. Next time we'll be looking at a map. And I've fixed my Discord link, so that one is actually valid. So if you want to join it, feel free to join it. If you have questions, leave a comment. And otherwise, see you next time.